Hi, and welcome to the fourth part of our tutorials on the basics of using SPSS syntax. Many SPSS commands can be used by typing very brief syntax, and if you know how to do this, you can use SPSS very efficiently. So in this tutorial I'll walk you through, just very briefly, through some often used commands, and those commands are listed here actually. And I'll use the data you'll see here at this location, and you can download it and rerun the analyses yourself. If you want to use other commands, or these commands but more sophisticatedly, you'll have to use the command syntax reference, as I explained in the third tutorial. Okay, so I'm going to start with the syntax file I created in the previous tutorial. I'm going to delete this, and as I said, I'm going to use a slightly extended version of the data, the tutorial 3 file. So let's run this, let's get the data, and let's also include the recode of the happiness variable we used before. Alright, so let's start with a couple of descriptive statistics. So I showed you the command means, but you know, maybe we want visual information instead. So maybe we would like to see a histogram. So let's ask SPSS for that. And it's very simple. You use the command graph. And you say what kind of graph, in this case a histogram, equals, and then the variable you're interested in, happy. Hit Ctrl R to run it, and you get a histogram. Now, one thing I said when we were talking about this recode was that our new variable, happy, doesn't have any labels. It doesn't have any value labels, and also not, whoops, let's resize that a little bit. It also doesn't have a variable label, which you can see here in the data view. Here it's empty. So let's create both. Let's create value labels and variable labels. So I'm going to do that here in the data transformations section, of course. And I'm going to cheat a little bit by just copy pasting the syntax like this, because otherwise this will get a very long tutorial. So two commands that are much alike: variable label happiness and value label happiness. So you specify variable labels, then the name of the variable, then the label. That's the first line. And for value labels, you specify the command value labels, abbreviated here as val-lab, then the name of the variable, and then all the different categories followed by their label. Alright, so let's run this, and let's see. Let's ask for frequencies to see if things worked out right. And they did. So here at the title you see the name of the variable, the label, and here with the values you see the different value labels. Okay, that's much better than before. So now we know frequencies, we know means, a histogram, all ways to get descriptive statistics, and there's also one other command, very straightforward, and that's descriptive happy, and this will give you the number of observations, minimum, maximum, mean, and standard deviation. Okay, let's switch to bivariate analyses now. So one thing we saw was that means happy by x007, which was marital status in our dataset, gave us group means. So quite nicely an overview with the different groups and their average scores on happiness. But I don't really like this name, the variable name x007. So let's rename it. The command is very simple: rename, and rename var. Then the variable you want to rename equals the new name, let's say mar stat, and run it. And then you'll see in the data view that indeed the variable has a new name, mer stat, which is much more intuitive than x007. But let's say we're interested in the same information, but we want it in a graph instead. That can also be done quite easily. Again, you use the command graph. In this case, let's ask for a bar graph. And now I want the means of happy again by, and now not x007, but mer stat. And you run it, and there it is, very nicely. A bar chart with the different marital status groups and happiness scores. But there's several other ways of getting bivariate statistics. So maybe we're interested in the exact categories of happiness. And that means that we're interested in cross tables. So let's ask for a cross table, abbreviated as cross, with happiness and marital status, like this. And I'm also going to specify what I want in the cells. I want in a sense not only the count, so the number of cases, but also the column percentage. And let's take a look. Whoop, this doesn't work. Oh, it needs the actually needs the by keyword here. So you always specify it as cross, the first variable by the other variable, and then you can specify if you want what you want in the cells. Okay, and then you get this. So quite nicely within the columns, the number of cases, but also the percentage. So for example, 55% of those who are married are very happy. Good. And if the variables you're using are continuous, both continuous, then you know, there are a couple of more options. One would be to draw a line graph. So again, a graph, and then a line graph with the means of happy, and let's say means happy by age, x003, which is almost continuous, and then you get something like this. Unfortunately, this is rather messy, and that's because of sample fluctuations. You can see that easily if you look at the frequencies of age. There are several ages where the groups are really small, so that's where you get sample fluctuations. And one way to get an idea about how the two variables are associated is to look at correlations. You specify core and happy x003, and there it is. It should be only one number, but SPSS gives an entire table, so it's a negative association, 0.085, and it's significant actually. So older people are less happy. But you could also try to fix this and show the negative correlation in a figure. And one way to do that would be to collapse all the ages in age groups, so that would cancel out part of the sample fluctuations. So let's try to do that. And we can do that by using recode. So again, I'm going to cheat a little bit, and I'm going to paste the syntax here. So create 8 groups by use of recode. Notice a couple of things. So I'm using int2 to create a new variable here, which is advisable, I think. I'm using the keyword through, so which specifies a range, so all values from 18 until 27. And here I'm using the keyword high, which has all values from 78 until the highest value get a score of 7. So I'm creating 7 age groups here. And of course you should give these groups also labels if you actually reporting this. So let's run it, and as I said, you should always carefully check the results of your transformations. So let's do that here by looking at the frequencies, and as you see, they have the same number of missings, which is very important. And as you can see here, there are indeed 7 groups, you know, with a distribution that seems okay. So this looks like everything worked out pretty nicely. Okay, so then we'll get back to our graph and then substitute. So we were here. Substitute age for age group and see what happens. And this is a much clearer picture. So it's not a really linear pattern, but it's clear that it's a downward trend. Okay, so let's switch to multivariate statistics now. Let's say we wanted to explain this. So why do people, when they grow older, why do they become less happy? And let's say that we think that it has to do with the number of people who become a widow or a widower. We could test that explanation by using regression analysis, but first we would have to create a variable that says whether a person is widowed, yes or no. So we're going to create a widow dummy variable. And as I told you before, the name of the marital status variable is marital status, so let's have a look at that one. So basically what we want to know is whether a person has a value of 5 on this marital status variable or not. And SPSS has a very nice trick to compute dummy variables. It's compute, or abbreviated as comp here. It's a new variable, widow. And we want that to have a value of 1 when marital status equals 5. So basically what SPSS does here is it gives widow a value of 1 when this is true, a value of 0 when it's not true, and it gives widow a missing value if marital status is missing. So that's exactly what we want. But of course we're going to check whether it's actually working what we're doing, like this. And here you can see that there are 83 respondents in the 1 category of widow, and that's the same amount here. And there are 6 missings, and there are 6 missings here, so it looks like everything worked out well. Okay, so let's go back to our analysis now. Let's gonna try regression, rec, specify the dependent variable, happiness, and specify which variables we want SPSS to enter in the equation or in the model. So we want eigen, of course, because we want to explain the relation between age and happiness, and then we want another model, so we can specify another enter equals, and we want widow in there. So what this will do is it will ask SPSS to make 2 models, one with age and one with age and widow. So just so you don't need to specify age again here, it will be included. This is not working. Oh yeah, right. So this was not in fact age, but it should have been x003. And there it is. Regression analysis with 2 models. And actually I think our idea made sense, because there was a significant effect of age when widow was not in the model, but when you include it in the model, and widows are clearly less happy, the effect of age disappears. Okay, if you want to know more about these mediation models, then there's another tutorial about them. It's also included in or on my YouTube channel. And then there's one final set of commands I want to show you, and those have to do with creating scales. what we're going to do is we're going to create a scale for religious beliefs. And we have a couple of variables, f050 to f055, with the information we need. A couple of questions: do you believe in God? Yes or no. Do you believe in life after death? Yes or no, etc. 5 different variables. So say we're interested in making a religious belief scale, and we want to know whether this would be a good scale, these 5 items. Well, one thing you should notice is that there are quite a few missings here. So one thing we may want to do is to count the number of missings across these 5 variables. So let's try to do that. It's not very complicated. It's the command count and then a name of a new variable, such as religious missing, and then the names of the variables you want to count across, and then finally between parentheses what it is that you want to count. In this case I want to count the missings. So let's run this and let's take a look at the results like this. And then, well, you see that there are actually quite a few people without any missings, but you know, also quite a few with 1 missing, etc. And there are even 2 persons who have all 5 items missing. Okay, another thing you usually want to do is calculate the reliability of the scale. And you can do that by simply asking for reliability variables like this, and then the set of variables you need like this. Just run it and you'll see that Cronbach's alpha of this scale is 0.819. So actually very good. And yet another thing you might be interested is in the question whether these items form one single scale, so whether they load on one single factor. And you can do exploratory factor analyses with the command factor variables like this equals, and then again the names of the variables you want in the analysis. And if you run this, it will give you principal component analysis. It will give you Varimax rotation, although it's not rotated in this case because it turns out to be only one factor. So it gives you all of the default settings. Of course, if you really want to do these kinds of analysis, you should get a good book from the library and make sure that you're making the right decisions. But I just want to demonstrate this syntax. And it turns out that's actually quite clearly one factor if you look at eigenvalues greater than 1. Okay, so I'd be inclined to think that this is actually a good scale. So let's try to create it. We can create the scale by taking the average value, for example, of all the items. You can also make a sum scale, but I like taking the average a bit better. So we can compute a new variable, abbreviated as comp. We're going to give it a name, say religious beliefs, abbreviated. And then compute always takes some kind of function. In this case, we want the new variable to be the function means, and we want it to take the means of these variables. And again, we want to take a look at the results to see if things worked out. Okay, so we have values between 0 and 1, so that looks good. We have 2 missings. So what SPSS does is, if we scroll up a little bit, so those 2 missings correspond to these 2 cases here. So those were the persons who had all items missing. So basically what SPSS does is, even if you have 4 items missing, so just one valid score, you're still going to get an average score computed. And it's something you can also overrule, but that's something I'll explain on another occasion. Okay, and then finally let's also do something with our scale. So let's compare, for example, men and women, and let's do a t-test. So let's test whether the group means are different, whether men and women have a different score on religious beliefs. We can use the command t-test groups. Then we specify the group variable. So in this case it's x001, has gender. And the variables, the values, sorry, so it's 1 and 2 represent men and women in this case. And then we specify /var equals and then the name of the dependent variable. Alright, and let's have a look. As we can see, the means are a little bit different. But regardless of whether we assume equal variances or not, it's not a significant difference. Alright, that's it. This was a very brief walkthrough, but nonetheless I hope it helps you in getting started with working with syntax. And good luck with that.